Hello, in this video tutorial I'm going to show you how to set external aerodynamics case in TCFD from scratch. For this video tutorial I will be using STLs of Burj Al Arab tutorial in TCFD. First thing I need to specify is TCFD file. I do not have any because I'm creating this tutorial from scratch, so I need to click on Save As and create new one. I'm going to create it next to my STL files. They are in directory Burj Al Arab on desktop. So I enter the directory and write the name of TCFD file, Burj Al Arab.tcfd. I press OK. Now I select simulation type. External aerodynamics cases use virtual tunnel simulation type. I press apply and I continue to tap physics. In section physics I have multiple subsections. First one is time management. In this subsection I specify if I want to compute steady state or steady state plus transient simulation. In this case, I will compute only steady state simulation. Besides steady state or transient, I can decide if I want to compute multiple speed lines. Speed lines allow me to compute multiple cases with multiple rotation speeds. But in this case, I do not have any rotation, so I leave it as 1. Also, I will be computing only one point. I want to change number of iteration because 500 might not be enough, so I want to increase it to large number to see how case converges, and if it converges well, it can end prematurely, or next time I can decrease number of iterations. So for the first simulation I will choose 5000 iterations. This is everything, and I continue to next subpart, fluid properties. This case will be incompressible. I will be computing with air around my building. I can leave fluid defaults. Reference pressure outside is 1 atmosphere, and yeah, I can calculate the age of air and add some passive scalars to be advected over my computation area, but I'm not going to compute these things in this tutorial. So it's everything, and I continue to turbulence. I will be using K-omega SST turbulence model with standard wall functions. I'm not going to change anything here, and I continue to rotation reference frames. If I had any rotation, I would specify it in second rotating reference frame, but my building Burj Al Arab is static, so I need only one static reference frame. This is everything. In physics tab, I can press apply, close physics, and continue to components and mesh. Here, the first thing I need to set is components. Here, parameter scale factor allows me to rescale my geometry if it's in different units than meters. Then there is number of components, where I can increase a number of my components if geometry consists of multiple of them, but in this case I will have only one component. Then there is bounding box. Bounding box allow me to set external aerodynamics cases easily, and with it I do not have to have STL files of my boundaries prepared. So I want to use it, and I'm going to check it. But before I'm going to specify the size of my computational area, I will load STL file of my Burj Al Arab. It's in desktop, Burj Al Arab and STL directory. I press OK. This directory is loaded. Burj Al Arab appears in patches table and I'm going to use it. I double clicked on type and I'm selecting wall because it's a building, so it's a wall. I press apply. Now building should appear in my render view, but it's not there because components are hidden. So I need to click on this eye, which was invisible before, and now it's visible. Some random paraview warning appears, but I don't care about it, and I can continue with my case setup. Here I have my building. Burj Al Arab is approximately 300 meters high, so bounding box with size of a cube 1 meter is not large enough and I need to increase it. First, I'm going to increase the bounding box in the direction of the flow. I want to flow to go in a plus x direction. If I want other direction, I can specify it here, but for me this is okay. I will increase the bounding box in this side to -1000 and plus 2000 as a minimum and maximum of my computational area. I can see that a line appeared here and it shows the beginning -1000 and plus 2000. Besides x direction, I also need sides of my computational area and I can specify them with -500 and +500. Now I have a 2D area, and if I also specify much larger height, I said that the building is 300 meters high or tall, then I need to specify at least 700 meters tall computational area to be for my area to be large enough. So I select 750. Now the computational area is reasonably large. The size of computational area influences the results a lot. Usually I want to use very large computational area, so my inlet, outlet and outlet boundary conditions does not influence the results around the building. So this was to computational area, size, and now I'm going to choose refinement levels. If I do not know what refinement levels there should be, I do this process iteratively. I specify some refinement levels, mesh the geometry, show it in paraview, and check it visually if it's fine enough. If it's, then it's okay. If it's not, then I need to use finer refinement levels. In this case, I know that my tutorial uses minimum refinement level 5 and maximum refinement level 6. It also changed the refinement levels of other walls, and I do not want that, so I remove Burj Al Arab building from group rest of the walls group, and now I can change these values separately. On the edges of my computational area, I don't need any refinement levels, so I use values 0 and 0. Now the walls changed, but Burj Al Arab stayed refined. Also, I do not want all the walls on the boundaries to be walls, only the ground is a real wall, and rest of boundaries should be wall slip. Oops. And Z maximum also wall slip. Zmin is ground. So this was refining, and I can also specify boundary layers, and in my case and tutorial I'm using 3 boundary layers on the Burj Al Arab and 3 boundary layers on the ground. No, this is on the other boundaries. I want it on the ground. So Zmin is correct. I press apply, and now I have an option to use gap refinement, but it's not useful in this case. Cylindrical mesh, also not very useful in this case. Then I have background mesh size. To specify a correct background mesh size, I have an option to show background mesh wireframe, so I see the size of the cells in my computational area. When I filled these values, now I have a wireframe around the building which shows me the size of a mesh in my computational volume. These are the values from tutorial, so they are okay, but again, if you do not know what values you should use, you should usually start with some values, mesh the geometry, check it visually and with check mesh to see if the mesh is correct, and if it's okay, then you can continue. Usually the finer mesh in the volume, the better. Mesh volume is very important because even if I have very large refinement levels on the walls and mesh is very large, then the computation can go wrong, because if I do not have small enough cells in the volume, then the error of simulation will be too high and it will not converge. So this background mesh size parameter is very important. Besides background mesh size, I'm going to set internal point. These angles are for adjustment of angle of my background mesh size, and I do not want to shift it in any direction, so I leave it as it is. I can hide the background mesh size for now, and then I can show internal point. Internal point appears in 0, 0, 0, and I want to make larger. Now I can see it better, and if I click on it and shift it, I can drag it to the other direction. Now I need to be sure that my internal point is in computational area. So I watch it from multiple sides, and I'm sure that's inside. What can be tricky, that internal point can be also inside of the building, but that would be incorrect, because I want to mesh external part next to my building, not the inside part of a building. If I wanted to mesh the internal part inside of the building, then I would need to shift or move my internal point into the building, and only internal part would be meshed. So this internal point decides if external part or internal part of my building will be meshed. Also very important parameter. I can hide it for now, press apply. And then I can continue to next parameters. I need to click on add layers because I added boundary layers in my patches table. And here I do not need to change the expansion ratio and the final thickness of the layer or thickness of the final layer. This setup is okay. Then I have an option to use refinement regions, which allow me to refine specific area of my computational area, but I'm not going to use it in this tutorial. The computational mesh will be already very large, but if you want to see how this refinement level is used, you can check wind turbine tutorial. There are refinement levels in that tutorial, so I recommend you to use that to see how refinement regions work. This is everything to components. I press apply and I can close components. Components graph show me how my components are connected, but in this case I have only single component, so the component graph is very simple. This is useful if there are multiple components and they are connected not in a straightforward manner, so this can help to see how components are connected. Then there are advanced snappy hex mesh options, but I recommend you to leave it as it is. If you do not know how snappy hex mesh works, those parameters are as default set very reasonably, and you need to change them only if you really know what snappy hex mesh does. So this is everything to components. I can continue to simulation. In this section I go to solver. In this subsection I can specify number of processors I want to compute on. My computer has 6 processors, so I will be using 6. I'm going to compute with default steady state solver and first numerical order. Then I want to use convergence check, and if I hover with the mouse over convergence tolerance, hint appears. And it says that if the sum of my computed values like mass flow rate and efficiency doesn't change for more than 0.1% over averaging window, the computation is considered to be converged and computation stops. I can specify averaging window here, so if I want to be sure that simulation is converged even after convergence check, I can increase averaging window and this condition will be more strict. I can increase it to 300. Then I can continue to controls, where I can change relaxation factors, limits for my variables like pressure and velocity, and then I can specify tolerances, absolute or relative. These values are set sensibly and I don't need to change anything in my case. If the simulation is unstable, then I can adjust this these values to help the solver to bound the unstable parts. Then there is option scripting, but I will not use scripts in this case. Then there are boundary conditions. First, inlet boundary conditions. In this case, I will be using velocity profile on the inlet, or fixed velocity, not velocity profile. I will be using 25 meters per second in x direction, and then I can specify turbulent kinetic energy and turbulent dissipation rate. I leave these values as they are and continue to outlet boundary conditions. Here I usually use fixed pressure or fixed mean pressure if I have velocity or flow rate on the inlet, and I can leave it as 0 pascals on the outlet. Then there are initial conditions. I can use 0 pascals because incompressible case does not need to specify exact pressure. Then I'm going to use 25 meters per second for velocity field, and I use the same turbulent values for turbulent variables. And the last part is post-processing. First post-processing subsection is report. Here I can specify which sections do I want to have in my report, what quantities should be used in report plots and tables, and also I can specify additional data files. This means if I specify data file with some data, I can add this data into one of my plots in report and compare the results. Then I can specify efficiency probes. I can choose multiple of them if I have multiple inlets, outlets, and different rotating patches. Here I do not have rotating patches, so efficiency will be very simple pressure difference between inlet outlet, computed from pressure difference. Then I can specify forces. I can add forces, compute them on all patches or only on Burj Al Arab wall if I select it, and here there will be computed lift, drag. If I select correct coefficient of rotation or center of rotation, then there is pitch, torque axis, reference area, reference length, and reference velocity magnitude. So this allows me to compute forces on my walls. This is all to report, and I can go to turbo machinery. Here, this case is not about turbo machinery, so I can skip it, only showing the options. Samples, I can add some of surface samples, and I can compute pressure on Burj Al Arab and save these values, save this value into file. For this case, it's only pressure, but if I had compressible or heat transfer case, it could be also temperature. Then there are probes, and I can compute or save variables pressure and velocity in specific coordinate. I can select any point in my computational area, and the probe will be computed and all data will be stored. I do not want to use probe in this case, so I can remove it with X, close this part and go to mist. Here I can write mesh and the results into CGNS format, or I can write surface quantities into separate file if I want to use them in post-processing for example, structural analysis. So this is everything. I click on save and check setup. My case setup is okay, and I can continue to TCFD manager, where I will be saving my case, meshing it and computing. I press apply. Window for report, residuals and quantity monitor appear. Now I can write the case. Case is written, and here I can continue with run all because I know that my tutorial mesh is okay. If I would be doing this for the first time, I would be meshing it separately, checking the mesh and the quality of the mesh, and even when I know that it looks okay, then I would continue to computation. Now I can press run all. And then I wait until everything is done. First meshing, then steady state computation. If present, then there is a transient simulation, and in the end, report generation. If I have some problems during a computation, or I want to adjust some variables during a computation, I can do it in manual runtime part. When everything is done, I can check the results after clicking on show results, or during the computation I can monitor quantities and the residuals. If the windows are too small, I can close some of them and make some of them larger. And if I want to reopen, for example, report with the results, I can click on another layout and click on the eye next to report, and report appears. If I want to open multiple windows in one layout, I can split layout and open multiple things. And this is everything to Burj Al Arab tutorial. Thank you for your attention.